of the things you guys asked me to go through was the different names of the groups on the periodic table and the different properties of those groups. So you're often asked these for group 1, 2, 7 and 8. You're asked maybe what their names are or a property of elements within those groups. So just a reminder, when we're talking about group, what are we talking about? So the periodic table is an arrangement of elements in order of increasing atomic number. So when we're looking at a group on the periodic table, they have similar chemical properties within each group. So a group, if we have a look, our groups are down the way. So this here is group 1. Okay, so going downwards. Then group 2 is here. Okay, then all these in the middle, we just kind of tend to skip and look at group 3 here, 4, 5, 6, 7 and 8. Okay, so we have 8 groups, and groups share similar properties. So we don't need to, like, let's say, learn the properties of lithium and then learn different properties of sodium. We just need to learn the properties within all of group 1 and then the properties within all of group 2, and then we'll also look at 7 and 8. Okay, so we said the columns, so the vertical columns are called groups. So for the first 20 atoms, the number group that they're in is the same number of electrons in their outer orbit. So my elements in group 1 will have 1 electron in their outer orbit. My elements in group 2 will have 2 electrons in their outer orbit, and so on. Group 3 will have 3 electrons in their outer orbit until we get to group 8 with 8 electrons in their outer orbit, or a full outer shell. So someone pointed out to me before, how come we have helium here in group 8 when it has 2 electrons in the outer shell? Well, my reasoning for that was because it had a full outer shell, because remember, we only have 2 electrons in the first shell when we're drawing our Bohr models. Okay, so you guys didn't ask me to revise Bohr models. Some of you did, but it wasn't a popular one. And yeah, I think the reasoning for that is because we drew a good few of them in class. Okay, then we also said the horizontal rows were called periods. So going across ways like this, we are looking at periods. So for something like hydrogen, okay, so hydrogen sometimes can be seen in group 1, and it's on the same line here, it's on the same period as helium. So both hydrogen and helium, if we were to draw them out with our Bohr models, so if I was to draw out hydrogen, we would see that it only has 1 outer shell. Likewise, if I was to draw out helium, it only has 1 outer shell. Whereas if I was to draw out something like lithium, we would know, because it's in our second period of group 1, that it's going to have 2 shells. Okay, it has 3 electrons in total, so we're going to have 1, 2, and then my first shell is full, and then my outer shell has 1 in it. So it was group 1, it has 1 electron in its outer shell, and it was in the second period, it had 2 shells in total. Okay, so we looked at the fact that groups here are going down the ways. Now, what I'm going to get you guys to do straight away is take down the different names, of group 1 here, group 2, group 7 and group 8. So they're the ones that we're going to look at. They can be asked often. Just making sure we're still recording. Okay, so I'll move this up. So we have group 1, first of all. That's the first one we're going to look at. So group 1 is our alkali metals. Okay, so our alkali metals. Okay, so what are our properties of our group 1 metals? So we can write this in as maybe a little subtitle, okay? And let's have a look at what are these properties. Okay, so we know straight away from it being in group 1 that it has 1 atom in the outer shell, in the outer orbit. Okay, they are very reactive. Why are they so reactive in comparison to, let's say, the ones in group 8? Why are they so reactive? Well, the ones in group 8 already have a full outer shell. The ones, let's say, in group 4, they're a little bit further off from getting a full outer shell, so they might not be as reactive. Whereas the ones in group 1, all they need to do to have a full outer shell is just get rid of one electron. So they're so close. So they really want it. Okay, so they're really reactive. So they want to get eight electrons in their outer shell so that they can be stable. So because they're so close to that, they're much more reactive. Okay, so the properties of these, okay, so let's have a look. So maybe let's split our properties into our physical properties and then just the general other properties. So our general properties is that, first of all, so we know that they're a metal. Why do we know that they're metal? Okay, well, there is metals is in the name. But remember, anything left of this ladder is a metal. Okay, so all of these are our metals here. And then anything on, I suppose, upwards of this ladder is a non-metal. Okay, so for these alkali metals, we have that they quickly tarnish. Okay, they tarnish quickly. Okay, so what I'm going to get you guys to do is take down these properties. So they tarnish quickly. Okay, so as metals, they tarnish quite quickly. Why do you think that they tarnish quite quickly? Why do you think that they do that? Well, they're reacting with the air around them so much easier than other metals might, because they're so close again to getting that full outer shell. They're very reactive, so they're reacting with that air. Okay, so because they tarnish quickly, they're stored in oil. Okay, so we store them in oil so that they don't react with the air around them. So they're stored in oil. Now let's look at our physical properties of these. Okay, so maybe I'll just go over here to do our physical properties. Okay, so my physical properties of these are... Okay, so my physical properties for these, well, they're soft and easily cut. Okay, so our physical properties of these metals is that they are soft and easily cut. Okay, so you can look up lithium, sodium, potassium, any of these, and see that they are soft and easily cut. Okay, they have low melting points. Okay, so we just need to learn these. So they have low melting points. They conduct electricity. So they conduct electricity. And our last one would be that they have a low density. Okay, so those are some physical properties of our alkali metals. Okay, so those are our alkali metals. So our next one, our next group 2, is alkaline earth metals. Okay, so these aren't as reactive as group 1, but they're still quite reactive. They don't have like big properties the same way as group 1 do. So usually we're just asked the properties if they're asking us about alkali metals. Okay, and the other one that that we might be asked maybe properties of could be the noble gases. Okay, our group 8 gases. So really these ones, guys, are the properties we need to know for group 1. Group 2, if you want to take some down, that they have 2 electrons in their outer orbit. They're not as reactive as alkali metals, but they're still quite reactive. Group 7, the halogens, they have 7 electrons in their orbit, so they're very highly reactive as well. So just like group 1, they're very close to having a full shell, so they are quite highly reactive. And then our group 8 are noble gases, or our inert gases. They have 8 electrons in their outer orbit, so they're very unreactive. Okay, they're quite stable because they already have an outer shell, so they don't really care about reacting with anything. Okay, So you guys asked me then to have a look at isotopes and to have a look at ratios of atoms in reactions. So we're going to do that now in another video.